Hello everyone, myself Ankur Patel, and today in this third session of projection of solid, we will continue our practice with problems of projection of solid. In the last session we have discussed an example of square pyramid. In today's session we are going to discuss an example of pentagonal pyramid. So let's start with the example. So the given content regarding the example is a pentagonal pyramid, side of base 30 mm, axis 60 mm long, is resting on HP and has one of its triangular faces perpendicular to the HP, and it is inclined at 30 degrees to the vertical plane. Draw its projection. So in this example, both the condition with HP and VP are given. So the example is going to be done in 3 different stages, and as you know that in the first stage we have to assume some things. So first of all, by taking the resting condition, we will try to derive the first stage. So here it is given that it is resting on HP and has one of its triangular faces perpendicular to HP. So first of all, draw the XY reference line, and as we are going to use the first angle projection method, the plane below the XY reference line will be horizontal plane and the plane above the XY reference line will be the vertical plane, and we will draw the top view below the XY reference line and front view above the XY reference line. So now right now it is given that it is resting on HP. So if the pyramid is resting on HP, for drawing the first stage we have to assume that the base of the pyramid is parallel to the horizontal plane and perpendicular to the vertical plane, and axis parallel to vertical plane perpendicular to the horizontal plane. So by assuming this data we will try to draw the first stage. So we will start with drawing the plan of the pentagonal pyramid in the first stage. So as you know that the plan will be the true shape of the base. Okay, so first of all we will draw the base, and base will gives us a true shape and it will be a pentagon. So draw the pentagon having side line 30 mm. Let us say that A, B, C, D, E. So this will be the top view of the base and it will be a true shape and it will be a pentagon. Now we have to draw the slant edges. As you know that the pyramid has the apex point and the slant edges. So first of all we will try to define the apex point, or we will try to draw the top view of the apex point. So to define the apex point, what we have to do, we have to connect this corner to the midpoint of the opposite edge like this, and likewise we have to take another corner and we have to connect it to the center of the opposite edge like this. So the intersection of this line and this line will gives us the center of the pentagonal plane, and the center will define the top view of the apex point. So here will be the top view of the apex point and it will be point O. Now we have to draw the top view of the slant edges. For that we have to connect O to A, B, C, D, and A, B, C, D are the base corners. So connect O to A, O to B, O to C, O to D, and O to E. These are the top view of the slant edges. And now right now we have taken the side CD on the right hand side of the drawing, because here the condition of the triangular face is given. So whenever the condition of the triangular face is given, we have to take the corner of the base on the left hand side and one of the side of the base on the right hand side of the drawing, and that side edge should be perpendicular to the XY reference line. Now we will try to draw the front view. So first of all we will draw the front view of the base, and for that we will project the base corners. So project base corners. This will be A dash, B dash, E dash, C dash, D dash. Connect A dash to C dash, D dash. This will be the front view of the base, because base is a pentagonal plane and it is perpendicular to the vertical plane. The front view of the base will be a line. Now we have to draw the axis. So first of all we have to draw the apex point. So for that we will project this corner over here, and now what we have to do, we have to measure the axis length, which is 60 mm from this point like this. Here we will get the front view of the apex point. Okay, and the axis height is 60 mm. That will be measured from the XY reference line. Now to draw the front view of the slant edges, what we have to do, we have to connect O dash to A dash, O dash to B dash E dash, and O dash to C dash D dash. So connect O dash to A dash, O dash to B dash E dash, and O dash to C dash D dash. This will be the front view of the slant edges, and this will be the front view of the pentagonal pyramid, and it will be a triangle. Now in the second stage, we have to derive the condition with the horizontal plane, because right now you can see that the pentagonal pyramid is resting on HP. So whenever the pyramid is resting on HP, in the second stage we have to derive the condition with the horizontal plane, and the condition with the horizontal plane is given that one of the triangular face is perpendicular to HP. Now you can see that the triangular face containing the edge CD, that is OCD, that means O dash C dash D dash, is a line, and right now it is perpendicular to the vertical plane. So it is possible for us to make this triangular face perpendicular to the horizontal plane, and if you want to make this triangular face OCD perpendicular to the horizontal plane, we have to make this O dash C dash D dash line perpendicular to the XY reference line. So now draw a line. This is O dash C dash, and right now you can see that this is a triangular face O dash C dash D dash, and it is perpendicular to the XY reference line. That means it is perpendicular to the horizontal plane. Now we have to copy this figure over here by using the reference line as O dash C dash D dash. So now what we have to do, we have to measure C dash D dash to A dash. If you want to mark A dash, what we have to do, we have to measure this length on the rounder C dash D dash to A dash. Take center as C dash and give an arc over here. Now measure A dash from O dash by using the rounder. Open your rounder up to O dash to A dash, and by taking center at O dash over here, give an arc over here. So here we will get A dash. Okay, so connect O dash to A dash and C dash to A dash like this. Okay, so this will be our A dash. Now what we have to do, we have to measure A dash to B dash E dash, and we have to give an arc from A dash over here. Measure the point of this axis also. So measure A dash to this point on the rounder and give an arc over here. Okay, now connect O dash to this point and show the axis over here. This will be our B dash A dash. So here we have copied this figure over here by taking the triangular face perpendicular to the XY reference line. That means right now you can see that the triangular face is perpendicular to horizontal plane. Now we have to draw the plan, and for that, first of all, we have to draw the projection lines and locus lines from the front view and the top view. And the observer is going to observe this figure from this direction. So first of all, take the projection of A, projector of BE, and projection of C. This is the projector of this axis line. Okay, now draw the locus from A, B, C, D, E from the top view in the first stage. Okay, so at this point we will get A1, at this point we will get B1, this will be our C1, D1 and E1, and this will be our O1 point. Now first of all, we have to draw the outlines in the top view, and as you know that outlines of the figure in the top view is going to be visible. So connect AB, BC, CD, DE and EE. These are the outlines of the figure, and outlines are always visible. Okay, now the observer is going to observe this figure from this side, but see, in this type of example, whenever one of the slant edge or the triangular face is perpendicular to the horizontal plane, in this type of case, all the slant edge is going to be visible. So in this case, no edge is going to be hidden. Okay, so all the slant edge is going to be visible in the top view. You have to remember this case whenever we will make any of the slant edge or triangular face perpendicular to the horizontal plane. In this type of cases, in the top view, all the slant edge is going to be visible. So the slant edge OA is going to be visible, OE is going to be visible, OB is going to be visible, OC and OD is going to be visible. Right now in the plan only CD is hidden, but you can see that the hidden line of the base edge CD is overlapped by the slant edge OC and OD. Okay, so this will be our top view or final top view in the second stage. Now in the third stage we have to derive the condition with the vertical plane. For that you have to read the statement again. It is resting on HP and has one of its triangular face perpendicular to HP and inclined at 30 degree to the vertical plane. Now the triangular face which is perpendicular to HP is inclined at an angle of 30 degree to the vertical plane. So first of all, what we have to do, we have to draw a line inclined at an angle of 30 degree to the XY reference line. Okay, this angle will be 30 degree angle, right? Now what we have to do, we have to copy this figure over here by drawing the or by taking the top view of the triangular face OCD at an angle of 30 degree. Okay, so here you can see that the top view of the triangular face OCD is showing this line OCD, and we have to make the triangular face inclined at an angle of 30 degree. So we have to take this side OCD, okay, OCD over here, and we have to copy this figure over here by taking OCD on this line. So copy this figure over here, O1 C1 D1, right? So first of all, what we have to do, if you want to copy this figure over here, we have to measure O1 C1 D1 from this figure. Okay, so measure C1 and D1 and mark C1 and D1 at the same distance by using the rounder. Okay, then after what we have to do, if you want to copy this figure over here, we have to measure different points by using this figure. So now what we have to do, measure D1 to A1 and C1 to A1, the distance will remain same, and from D1 give an arc over here like this, and from C1 give an arc over here like this. So you will get A1 over here. Now what we have to do, we have to measure A1 to E1, A1 to B1, and we have to give an arc from A1 like this. Okay, and then after we have to measure E1 from D1 and B1 from C1. This distance will also remain same. So measure D1 to E1, give an arc from D1 and give an arc from C1 over here, you will get B1. So like this you can copy this figure over here. Okay, now we have to draw the front view in the last stage. So first of all, we have to derive the position of the observer. So observer is going to observe this figure. Now we have to draw the front view in the last stage, and if you want to draw the front view in the last stage, what we have to do, first of all we have to take the projections from the elevation in the second stage. So like this will be the projector of O dash, projector of A, projection of C and B and center, and the XY line will be the projection of CD. And then after we have to draw the projections from the top view. Okay, so draw the projection of A, this will be our A1. Draw the projection of B, this will be our B1, C1, D1, and this will be E1, and this will be our O1 dash, right? Now we have to, if you want to draw the front view, first of all we have to derive the position of the observer. So observer is going to observe this figure from this direction. So right now you can see that the apex point is nearer to the XY reference line. That means it is away from the observer, and the base of this figure or pyramid is nearer to the observer. So whenever you are drawing the elevation in the last stage, you have to derive the position of its base with the observer. If the position of its base is nearer to the observer, base is going to be visible in the elevation. Okay, so right now you can see that the base is nearer to the observer because apex is nearer to the XY reference line, it is nearer to the vertical plane. Okay, and base is away from the vertical plane, but base is nearer to the observer. So whenever the base is nearer to the observer in the elevation, the base is going to be visible. Okay, so connect A1 dash, B1 dash, C1 dash, D1 dash, E1 dash. It is going to be visible. So A1 B1, A1 dash, B1 dash, B1 dash, C1 dash, C1 dash, D1 dash, D1 dash, E1 dash, E1 dash, A1 dash. Base is going to be visible because base is nearer to the observer. Now we have to draw the slant edges O1 dash A1 dash, O1 dash B1 dash, O1 dash C1 dash, O1 dash D1 dash, and O1 dash E1 dash. By taking the condition in the mind, which is two visible line will never intersect and two hidden line will never intersect. So if we will connect O1 A1, O1 B1, O1 C1, O1 D1, O1 E1, this slant is if this slant edge is going to be intersect to the visible outlines of the base, it is going to be hidden, and if it doesn't intersect, and it is going to be visible. So now connect O1 A1, it is going to be visible because in between O1 and A1 we doesn't find any visible edge which is intersecting O1 A1. Okay, likewise O1 B1 is also going to be visible, O1 C1 is also going to be visible because we doesn't have any visible outline in between O1 and C1. O1 dash D1 dash is going to be hidden because now you can see that in between O1 dash D1 dash this slant edge is intersecting A1 B1 dash. So we can say that O1 dash D1 dash is going to be hidden because the rule is two visible line will never intersect and two hidden line will never intersect. Now we have to connect the last edge, which is O1 dash E1 dash. It is going to be visible also. Okay, because it is in between O1 dash E1 dash, we doesn't find any visible outline of the base, or no visible outline is intersecting O1 E1. So this will be our final top view and the front view. Now if you want to show the axis in this figure, we have to mark this point over here, or point of the axis over here, and then after we have to project this point like this over here. It will intersecting the line projector of the axis over here. So connect this point to the apex point, it will be the front view of the axis. Okay, so this will be our final front view and the top view in the last stage. So this is it for today. Thank you for watching. See you in the next lecture.